Lab guy here. Let me explain what it is I'm trying to build. This is a high power amplifier for driving deflection yoke coils directly. It would work in the same way that a stereo amplifier drives a speaker. So in this case, if you look at the extreme left, you see I have a regular input control followed by a level control going into a stage with a gain of 2 made up of the max 4395. The negative input of that amplifier is hooked to a bias network which allows for DC offsets. So if you have unipolar drive coming in, you can offset it so that you get a plus and minus current drive at the output. This drives the high power LH0101CK high power op amp. This thing is capable of 60 watts of power. I'm not even running 10 watts with this design. My design can't deliver enough current to the op amp in order to reach full power, and I'm not trying to do that. This is going to be driving camera deflection yokes, and those should not require the kind of power you'd see like in a 25-inch arcade monitor, for instance. The power supply starts in the lower left and passes through each power line passes through 3 3300 microfarad capacitors to put some charge storage on the board. There's 2 5-volt regulators for driving the 4395 op amp, and the 15-volt rails go directly to the op amps through heavy twisted copper wire. In part 2, we had reached this level of construction. I have all 3 op amps mounted to my board and nothing else. As I continued to work on this, I continued to have problems with the power transistor style cases shorting through the heatsink back into the ground plane. So a repair was required for that. And so at that point I got out the Kapton tape. This helped to isolate the heat sinks from the ground plane beneath. I guess the anodizing got scratched, and the outer casing of the IC was shorting through that to ground, and it kept going. So I had enough, and I simply pulled both parts back off and covered the board with the Kapton, and that solved the entire problem. Now it's time to put the Max 4395 quad op amp module on the board. Got to line it up. It must be perfectly centered, or my OCD goes crazy. Now it's time to permanently attach the Max 4395 quad op amp to the main breadboard, to the main vector board. So here I'm tacking the power pins down and lining it up so that it's perfectly flat. After soldering the rest of the pins, I'm now going to use solder braid to attach the ground plane of the little breadboard to the main board. First, I tin the ground plane on the main board. The ink from my permanent marker does not interfere with soldering. Next, I put some solder along the edge of the adapter board, so there's something for the braid to solder to. Put a bend in the braid, tack it to primary ground. Then clip it off. Kind of press and shape it so that it's in good contact with the copper, or in this case gold-plated copper. Only the best for a lab guy. And then we solder the two grounds together. I do this again on the other side. You can see that I'm putting the ground plane right at the ground end of the bypass capacitor, so that in essence it is connecting directly from the pin of the chip back to the primary ground on the board. On the bottom of the board, at those same two pins, I installed 10 microfarad, 25 volts on each pin, and tied it to ground also. And its ground is also up through the board, through the pads of the board, right to the same spots where the braid is grounded. So all of the grounds are truly common for this part. The next two parts to go onto the board will be the plus 5 volt and minus 5 volt voltage regulators. These provide plus and minus 5 volts for the max 4395. They both have heat sinks, though I don't think they'll be using that much power. They might, I don't know. Next, I fit the potentiometers to the board. That looks like a good spot for them. These will be soldered in. Slowly, I became aware that something wasn't right. These regulators and heat sinks are very delicate. You bend them too many times, they break off. But wait. That is why my projects don't look beat up when I'm finished building them. Stay tuned for part 4 coming up next, where we continue construction of the dual amplifier.